Here we have a problem that's pretty straightforward as long as you know a couple things about the coordinate plane and about finding area. First thing I want you to notice on this is this reference symbol. That means that you can use the reference card. Now I may not have shown you the reference card for this problem because the only thing that you need for this one is the area of a rectangle. The area of a rectangle equals length times width. And that's pretty easy to remember, so I didn't give you the reference card for this one, but you will be able to use the reference card on different problems. It says a city planner created a model of a park as shown on the grid below. The fourth corner D of the rectangular part is missing from the model. I had one person that made this beautiful little cutout picture and got the area of that, and it was really good. But the problem is they didn't really follow the instructions. The corner D is missing. So the corner D, since it's a rectangle, the corner D goes right there, D. And then here is your rectangle. Oops, it doesn't really go on the lines, but you see what I'm talking about there. So there's your rectangle. Now we need to find the coordinates. Whenever we do coordinates, coordinates are going to be x comma y, where x is the horizontal axis and y is the vertical axis. So x comma y. So for A, to find the coordinate for A, right here is the origin. And I'm going to make this in blue. Right here is the origin, so I go 1, 2 to the left, and then 1, 2, 3, 4 up. 2 to the left is -2, and then 4 up above the x-axis. Above the x-axis is positive, so it's -2, 4. The B value is 1, 2, 3 to the right, and then 1, 2, 3, 4 up. So it's 3, 4. And then the the point C is 1, 2 to the left, which is -2, and then 1, 2, 3, 4 down, which is -4. And the last one, D, the one that we made, is 1, 2, 3 to the right, and then 1, 2, 3, 4 down. So it's 3, -4. So your 4 points are -2, 4, 3, 4, -2, -4, and 3, -4. Now the rest of the problem says the distance in units between point A and point B represents the width of the park. So let's find the width of the park first. Let's go back up here and find the width of the park. Now let me redraw in that point D. Okay, so between A and B, starting at A, I go 1, 2, 3, 4, 5. So the width is 5. And I'm going to draw it just like that. That's how I'm going to show my work to the blue-haired old ladies here. Because remember, the blue-haired old ladies want you to, whoops, they don't want you to do that. They want you to show all work. Now there's not a lot of ways you could show a lot of work on this because there's really not a lot of work to do, but this is a really good way to show all work. It also says the distance in units between point A and point C represents the length of the park. So now let's find the length of the park between point A and point C. Let's go back up here to the park. And between A and C, I got starting at A, 1, 2, 3, 4, 5, 6, 7, 8. A distance of 8. Now a lot of people put a distance of 6 and a distance of 9, but you do not start with that first point. You have to, from A to this point right here is a distance of 1. It's not a distance of 2. That's very important. If I have this line segment, and I have this line segment, it does not have a distance of 1, 2, 3. Starting here, from here to here, it's a distance of 1. And then from here to here, it's another distance of 1. So this is a distance of 2, not 3. So let's look back down here, and it wants to know what the area in square units of the park is. Well, we know we have 8 by 5. So all we have to do, since area is length times width, we just multiply 8 times 5 equals 40. And we got 40 square units. And that's really all the work that you can show. We've got the points up here. We show up here where we've got the distance. And then down here, 8 times 5 equals 40. 40 square units.